Hi, welcome to extending the lightweight render pipeline. For those who don't know, my name is John Sietsma. And so this plan for today is just to give you an overview of the pipeline, how it renders things, so you get the context where we're at. And then I'm going to take you through 3 examples total for extending the pipeline. And I'm happy to take questions at the end and talk about it more, but let's dive in. So what is what is it all about? So first of all, why do we have the lightweight render pipeline? So considering you're at this talk, you probably know we have these new rendering pipelines because Unity default renders a bit of a black box, and we're doing things from low-end mobile titles all the way up to high-end titles, and so we've made our render pipeline scriptable and provided 2 render pipelines that you can modify and use. And I'm going to be talking about the lightweight render pipeline. I don't necessarily like the choice of names because lightweight makes it sound like it's not going to be very capable and, you know, kind of puts people off a little bit, but I really love it. And the reason is, so let's talk about, you know, what it is and what it can do. It's actually not that far off what our default renderer does, which is why I don't necessarily like the lightweight kind of thing. Some of the differences are, this is a single pass forward renderer, whereas our default one is a multi-pass forward renderer. So every time you add a light, now default renderer, you get an extra pass. Here it can pick up to 8 lights at once and pull it through in a single pass. So there are some things missing. There's no real-time GI. And there are some missing features like some of the mixed mode lighting that you might be used to. A couple of those have dropped out, but they'll come back in over time. And there'll probably be things in the future like a deferred option as well. So as we start to build more features into this, we'll get more and more features coming on. And it has much better batching. So we've published some performance stats as a blog post that breaks down sample scenes with the default versus the lightweight renderer. So if you're interested in the performance side of things, look that up. But generally, most of the time, you get just better performance just by porting because it's single pass and we can do better batching. We put shader parameters in a constant buffer rather than pass them in, so we can batch across materials now. There's some improvements like that just get you better performance. And so why would you want to extend or customize this? Well, one, it's been built to be extendable and customizable, which I'll show you. It's pretty easy to do. But you might find that lightweight doesn't do what you want, so there's a missing feature you'd like to add. You might want to add some VFX, like today I'm adding a couple of effects, that sort of thing. You might want to add some render passes for that. But if you're a bit more ambitious, you might want to implement a forward plus renderer or write your own lighting or do something like that, and that's when you're going to dive in here and start making modifications. So let's just have a look at what happens in a render frame for the lightweight render pipeline before we look at how to make our own render passes. So there's nothing, I mean, if you're familiar with rendering, there's nothing too surprising here. The other thing I like about the lightweight render pipeline is pretty simple. When you have a look at the code, you can fit most of, you know, the render pass on one page. And so you can read it, pass through and see this setup. So we set up some camera data and some shader constants for lighting. What's the lighting we have? So this is per camera, and we're going to cull some objects. So we're going to go through and you can feed it different parameters and about what you'd like to cull and how. And then it's going to also cull some lights. What lights are touching this particular object? What are the most important lights? So you get basically a list of things that you're going to render this frame. We execute a bunch of different passes, which I'll dive a bit into soon. And then once we've done all that, that generates a whole bunch of rendering commands, which we then submit. And this is what it looks like. If you get the frame debugger up, and I'll use the frame debugger quite a bit on here to show you the breakdown of what's going on here. This is a sample of what the render passes, the render pass part. So jumping back to here for a moment, we're going to be talking a lot about the render passes part of this stack as we go on. So the render passes part of that in a simple scene looks like this. There's no transparent objects in this one, otherwise it'll be a transparent pass as well. But you know, we render the shadow map, depth pass, shadows, opaque and skybox, and then composite it all together. Just want to make sure we've got the right terminology here. We're all on the same page about what a render pass means, because a render pass can mean many different things. For this particular instance with the lightweight render pipeline, it's not well defined. It's pretty much a render stage hook. You can write some code that's going to happen at a certain stage of rendering, you can do whatever you'd like with it. These are some usual things you would do. You would send up some rendering data, instancing support, that sort of stuff. You could draw a bunch of stuff. You can create and set render targets, and you can select which shader paths you're going to use. This is different to a rendering path. So in a shader, you can have different shader paths, like a depth path or a lighting path, and so you can select which one you'd like to use. You can filter objects further, which again I'll show you code and examples of how to do this. And you can also execute command buffers. So previously, if you've done any rendering extension kind of stuff, you've probably used command buffers in the past. It's a class that lets you execute commands like blidding and so forth. This still uses command buffers a lot, so all that stuff will still be familiar to you, but it lets you do some other things around it, like set up rendering data and filtering and culling and this sort of stuff as well. And that's just tiny, so you won't be able to see this, but this is, again, the frame debugger. And this shows, if you go to the frame debugger, it shows the passes, which I showed you just before, but it also shows you things like the shader variables that have been set, culling mode, blending modes, etc. So there you go. I just wanted to give you that quick overview so we're all on the same page about what we're talking about, why we have it, how we'd like to extend it, and now I'm going to go you through a practical example of how, now I'm going to go through how you make these things, then we'll go through some examples. So as we said, a render pass is just a hook at a certain stage. You can do what you'd like. How do you create one? I realise this code is quite tiny now. Can you see that up the back? A little bit? I'll spell it out a little bit. Basically, we have a subclass. Like you have a mono behavior. You have a subclass of scriptable render pass. And it has one method, one abstract function you have to override, which is the execute. And you get some context from that, like the renderer state, a context, and you're expected to fill out some rendering data. That's all you have to do. So like I said, you can put whatever code you like in there. It doesn't really matter. There's a few other things you can do here. So there's this optional override here for frame cleanup. So if you're creating render textures that you want to use later on in the render pipeline, you would want to use the cleanup then to release those render textures once all the passes have been done. So fairly easy to create the render pass. How do you actually tell the renderer to use it? Well, you queue it up at a certain stage. So here we have, again, a class, and it's implementing an interface called IAfterSkybox pass. There's a whole series of these, and they all have much the same sort of interface. In this instance, it's called getPass2enqueue, and so in this here, you're just expected to return that pass that I showed you before. You create your custom pass, I'm implementing an interface is saying I want this to happen after the skybox, and I'm just going to return a new object. Okay? And these are the hooks that you get. These are the interfaces that you can implement. So this is an order of rendering by default. So after the depth, after skybox, or after everything's been rendered, you can do this. So let's go through an example. I want to actually show this in action. So this is maybe familiar if you've done any command buffer stuff before. This is one of the command buffer samples, right? This is the reflective blur that came when command buffers was originally released. So this is actually a screenshot from the port, not the original one. But it looks exactly the same. So how would we do this technique? What would we do? So in default Unity, you would use some command buffers. The technique here is still the same. What we're going to do here is take this wall, or this wall object here at the front, and we're going to render that later on. We're going to render that in the transparent pass. So I'm going to render everything else, I'm going to render these capsules and the plane, and then after all that opaque rendering's been done, I'm going to capture the color buffer, blur it, and then when I render this wall at the front, it's not actually a transparent object, it's actually an opaque object, but I'm going to take that texture that I've put out and apply this little normal map to it and paste it on, right? So I'm going to pretend it's transparent, but I'm actually just going to get the screen and do some manipulation on it and paste it back on. So how would I do this in the lightweight render pipeline? There's reams of code here. I will share this code afterwards. I know it's against slide rules to do reams of code, but I didn't want to jump back in and out of the editor here, so I thought I'll take the risk of doing it this way. And And again, I'll just talk you through the main thing of it. It's not important what every line says here. It's just I want to show you the main steps of what we're doing. So I showed you before when we have our scriptable render pass, we have a place where we can, when that pass is going to get executed. So I've told you the main steps we're going to do here. We're going to get a copy of our color buffer here. So we have a blit command. Again, we're using command buffers. So anything you've learned with command buffers or the references for command buffers are still current. You can still use them. I'm going to create 2 temporary render textures that are a quarter size just for performance reasons. And I've kind of hidden it away here, but there's this setup command buffer here which just ping pongs between those buffers with a blur shader. So I just blur those 2 buffers together. And then the last thing I do is just set a global texture parameter here, grab blur texture so it's available later on. Okay, so this is the whole pass. All I'm really doing is a series of blits with a blur shader. By the way, there is a GitHub repository for all of this that I'll share the link at the end as well. So all this code and this project will be available to you if you wanted to go and have a dig deeper into any of this. And then the shader, again, it's really the intent of here I want you to get rather than the code itself. We can see at some stage we get the grab blur texture. We just look up that texture that I set the parameter for and apply it to our object. That's really what we're doing here. And when I have this in action, this is now what you saw the default render passes here. And now, 5th one down, I've now got this blurred grab pass that has been inserted after opaque rendering. And then that captures that color buffer, blurs it, and then when we render the transparency, that's when we apply it back to our object. So we can see we've managed to insert a render pass here. Let's go on to the second example here, which is just a little bit more complicated, shows up a little bit more of the features of of the lightweight render pipeline and doing a custom render pass. This one here, you can see it's still got the example of the blurred refractions going on here, but you can also see that I've got some per object blur. So these arrows at the back and that light down the bottom on the side, there's no actual lights, and they aren't actually lights, they have an emissive texture on them, but I've got glow just on those objects, so they shine and show off. So if you wanted to do this in the default renderer, you'd probably set up another camera and have it just render just those objects to capture it to a render texture, and then use command buffers to pull those in and do something with it. But it's a little bit more of a setup. You have to add an extra camera to your scene and manage that somehow. It can be done. There's things on the asset store, but it gets a little bit easier in the lightweight render pipeline because we can just do it in all in one block of code. So the technique for the per object blur, it's fairly straightforward. What I'm going to do is, in the scene, I'm going to mark some objects as these are the ones I want to blur. And what I'm going to do is I'm going to render just those objects to a stencil. So I'm just going to have a black and white image. I'll show you this in Unity in a second. I'll have a black and white image that just has where those objects are. And that's all I'm going to do in my render pass. I'm just going to draw a stencil. And what I have is a custom post-processing step. So I'm using that post-processing stack version 2, which lets you put a custom post-process in. And in that post-process, I'm using that stencil to stencil out to just get the objects I should be blurring. So I've got the color buffer, I use that stencil to get those out. I blur that texture and then add it back, just copy it back over and add it back on. Okay, so again, I'll show you the code for this. I'll show you this in Unity. This is when I will flick over. But again, it's something that'll be a bit trickier to do in the current setup. That's a little bit easier now to do. So again, lots of code, which I'll talk you through. So this is the render pass. This is not the actual render pass itself. This is the constructor for the render pass. So this is where I'm going to set up, when I first create my render pass, what I'm going to set up. So there's a few things I'm going to grab here. One is, the first line here says register shader pass name, lightweight forward. So what I can do here is we have shader passes. I mentioned this before, like we can have a depth pass or an outline pass, also lighting pass, all these different passes. This register pass name, I'm not creating this. I'm just saying when I render, it's almost like a filter. This is the pass I want to use. If that pass didn't exist, nothing in any shader, then nothing will get rendered. So it's pretty much a way to say to selectively change how I render things in my scene, or selectively change what I render. The lightweight forward string there, that's what in the lightweight render pipeline, that's what every shader is now tagged with. So this is just going to render all the default objects, basically. I just keep the base descriptor of the render texture. This gives me information about the size of the buffer we're rendering to. And this next line here, I'm getting the existing stencil shader. All this does is write white values, render black values when it renders an object. So it's a really cheap thing to do. And then I create a render target handle. So the lightweight render pipeline has some new functions to help you deal with render targets. You can just, previously all you had was an int before when you created this, and you can still do that. All this class does is wrap that up for you, just stores an int for you. Now this is the important one here. So what we're talking about here is we're going to render the scene, and I've already told you about one filter. I can choose which shader pass I'd like to render. Here's some other ways I can filter what I'm going to render. Now you remember, I just want to render the objects I want to bloom. Okay, so I'm going to say, please render all the opaque objects. This only works for opaque objects. And then the next one here has a rendering layer mask, and I've set that to some number. I'm just going to flick to Unity to show you actually where that is. So there's this layer up in the top right-hand corner here, which you can also filter by that as well. So you can filter just things on a certain layer. But every renderer also now has a render layer mask here. And it's just a series of numbers you can set. So I can use that to filter what I'd like to render as well. Now, numbers are a little bit hard to deal with. So I also wrote, for this example, this little helper class here. You attach it to an object, and it just sets the object to that render layer. Okay, so you don't have to tell your artists, if you have to set bloom, you have to remember which render target to set to. You just say, drag the script on, and it's going to set it up for you properly. Any object that has, any renderer that has this script on it is going to become part of our, is going to get a per object bloom on it. Okay, so this is our render pass. And this is where we start to put our filters in action. So first thing, remember this is the step where I want to create a stencil. I want to create a stencil of the things I need to apply blur to. So the first thing I'm going to do is set the render target to be that stencil. I'll just give it an ID and say, okay, I don't want to render to the main screen here. I'm not actually rendering objects. I want to render to the stencil buffer. And then I clear that. So remember at the start I said there's various things we have to do here if we want to render, like set up camera data and do culling and these sorts of stuff. So there's some helper scripts for this. I'm calling create renderer settings and just taking the default settings. This is a stage here if you wanted to do something with blend modes or culling or something like that, that you come in here and say, okay, I'm going to change actually how I render something. If you wanted to switch to a different camera mode, for instance. This next line here, set override material. So I'm going to render everything in the scene with my stencil material. Just going to use that material instead, this really simple stencil material. And then I'm going to render everything. So it's just going to render everything with that shader pass name, marked in a certain way. And then I just set my global texture similar to the last example where I say, okay, that stencil I've made, it's just a shader. Now it's just going to be a shader parameter that you can drag in whatever you want. And that's it. I've created my stencil. I will show you this in action in Unity. I'll jump over because I know there's a lot of code here and it's hard to maybe visualize what all the steps are, but we'll see it soon. Now this bit has nothing to do with the lightweight render pipeline. This is my post-processing stack. So you can create a custom post-processing effect. It's pretty simple to do as well. In this one here, this is quite similar to what I've showed you already. It's just going to blur the buffer. So I create a couple of temporary render textures. I use my stencil to blit the color buffer, only where the stencil is there, above a certain threshold. I set up my command buffer for blurring. And then the next step here is I take my blurred stenciled color buffer, additively put it back on over my original color buffer. So I've got that blurred stuff here, I put it back on again, and then I bleed it over. Let's have a look at that in action, just so I can make that a little bit more concrete for you of what this actually looks like. So this is the scene here. I've got both effects. Let's look at the frame debugger, because this is an easy way to see what's going on here. I'll zoom in so it's more visible for people. So I've put in 2 render passes here. This is both techniques at once. So I've got my per object bloom and my blurred grab pass. And so you can already see here what the result of per object bloom is. That's the stencil that I generate from the objects I want to blur. So I'll dive into that a little bit. So this has all the filtering I told you about before. So like I mentioned, you get nice batching with lightweight render pipeline. So all those objects I've marked have just getting drawn in one draw call. So all those meshes, because I've got the same material on them, you can just do one draw call and create the stencil. So this is a super cheap operation here to do. And so this is the stencil part. We can see it's using the stencil right shader that's built in, and it just takes all those objects, those filtered objects, and generates this stencil buffer. Then we do the blurred grab pass again. You can see that in action here. We have a quarter size. I'll see if I can get both on screen at once. So we capture our buffer, make it quarter size, do the blur steps, and set that to a global texture. So now we've got 2 textures. We have a stencils texture and our blurry grab pass texture. To complete this, now we render our transparent objects. So we render the blur mesh wall. We can't see the result of this because it's not going to the back buffer directly, but this is where we draw that wall and reapply that texture. And last thing we need to do is the per object bloom. So here we can see our post-processing effects. And so we have our built-in effects, like I've got auto exposure on at the moment. I don't have that many effects on. And I've got my custom effects here. So let me see if I can I'll zoom out here again so you can see this. So this is really similar again. Remember, I've got my stencil. So I've used my stencil here to just get the arrows and the light out, right? So I've used that stencil to copy over the color buffer. I blur that and then bleed it back over the top. So we now have this per object bloom going. And finally, pull it all together. So that's a brief overview of how you can add your own render pass. I know there's a lot of rendering jargon in there, but hopefully there's bits you can pull out of there and again pull down the examples and go through this. What I imagine will happen is people will start to make these effects and put them in the asset store as well, so you can download them and grab them. But by all means, jump in and make your own effects as well using this process. So what if we wanted to go further? What if I wanted to create my own deferred renderer, for instance? So I have my own deferred renderer. I don't want to have the same render passes I've had before. I want to have my own render passes. But I don't want to write my own render pipeline. So you can write your own render pipeline. It's just a lot of work, right? We want to use a lot of the stuff that's built into the lightweight render pipeline and not have to create all my own passes. So it'd be really nice if there was a way I could just add my own, decide which render passes I want. So here, this is how there's this iRenderer setup interface. You can implement that. If you do that, it's up to you to queue the passes that you want, right? So rather than the default opaque, skybox, transparent, whatever. Now those passes are still available to you. They're still there in code, so you can still queue all the passes you want, and you could recreate the renderer that's there pretty easily. But in this example here, I'm going to show you a deferred renderer. But this could be a forward pass or your own lighting pass or something like that. So here we have our iRenderer set up, and I'm just queuing one pass in this example. Now it's strange that there's only one pass, but I'll show you why in a second. So you expect more than one. But here's where you would queue any pass you want, including the ones that are actually part of the lightweight render pipeline. Right, so this is a potentially confusing naming thing, and I've talked to the team about this. We have a scriptable render pass, which is you do what the hell you want at some stage in the rendering. There is also a render pass class. Now, what does that mean? This is more strictly what a render pass usually means. It's I'm going to have a render target. I'm going to make a series of draw calls to it, and then I'm done. So this render pass here, it takes a bunch of render targets. So in this case, it's taken in a diffuse buffer, a specular buffer, a normal buffer. So these are what I'm going to write to. And the interesting thing about this is that some of the newer graphics APIs like Vulkan actually have render passes as a first-class object. And so when you have things like this, where you're saying I'm using this render pass with this render target, and I'm going to use this one down here with this render target, it can actually reason about dependencies and perhaps do things in parallel that it couldn't do before. So you get some efficiency out of this, and we will, when the platform supports it, this render pass will make use of those APIs. So the next thing we see here is that there's two subpasses. There's a subpass that takes in this diffuse, roughness, G-buffer camera, and then there's a subpass that does all the lighting. So what does the subpass part of this mean? What this means is that all these buffers I've configured up the top when I do my render pass, they all stay bound or available to your shaders as you go through. So again, this is a performance thing. If I was doing a deferred render and I was writing to these buffers, I might write to them, might drop them, and I have to rebind them later on. Now they all stick there, and again, it's going to be a more, if the graphics API supports it, it's going to be a more efficient workflow. So let's have a little bit of a look at these passes as well. I've got this G-buffer render and a light renderer. I'm actually going to go to the project. Actually, yeah, no, maybe I won't dive into that. The G-buffer shader has multiple render targets it writes to. So it writes to a diffuse target and a normal target and this kind of stuff, and then the lighting pass takes all those in and does the lighting pass. So if you would like to check this out, here are some resources for you. I know this was a very technically dense talk, so I'm happy to, if you come up afterwards, I can dig into this. I've got the project here, and you can ask me more questions about it, or I'm a little bit ahead of time, so we can ask questions now as well. The first link here is Arturo, who is actually here today. He's our Mexican evangelist. He just collated all these resources from the scriptable render pipe generally, like all the blog posts, all the talks you might want to see, examples, just put them in a GitHub wiki page, and that's a really great resource to start from, because there's lots and lots of resources about the scriptable render pipeline in general, even if you don't want to extend it, including the high definition one. And the next link here is a link to the GitHub repository that I've been for this project. Now, if you're going to look at it, also check out the wiki. I've filled out a wiki for this project, which has a lot of the same information about an overview of the rendering process and what's going on in it, but probably one of the most fleshed out sections is a guide for if you're writing shaders for the lightweight render pipeline. What are the differences between shaders you write for the default pipeline and this one here? You can use if it's unlit, you can use the same shaders, but there's just some kind of library changes and some macro changes and stuff like that you should be aware of, so you can at least start writing shaders with a new style, or perhaps writing a shader that has one pass for the lightweight, one pass for a custom, one pass for high definition, for instance, right? So you can get the same shader that handles different pipelines. I mean, if you're writing effects, so you should probably use the shader graph, because it's going to know which pipeline you're using and compile to the right shader for you. But if you want to write your own shaders or in that position where you're porting something, then I've got a guide there that can help you out with the details of, okay, this macro doesn't work anymore, which one should I use instead?